So in this video, we're going to be solving trigonometric equations in quadratic form. Identities that we're definitely going to be taking advantage of here is the Pythagorean identities. Cosine squared x plus sine squared x equal to 1. Okay. So like, say you had a cosine squared x and you wanted to replace it in terms of sine squared, you could subtract sine squared x from both sides. And so now I can rewrite cosine squared x as 1 minus sine squared x. Okay, the goal here in these types of problems is if you got a mix of sines and cosines, see if you can rewrite that quadratic term in terms of the same cosine or the sine, and then see if you can factor or use a quadratic formula, whatever you have to do to figure out what the actual solution is. Okay, so let's work a problem. So we've got solve the equation 2 sine squared theta minus 3 sine theta plus 1 equal to 0. Okay, and I want to do it on 0 to 2 pi. So this equation is quadratic in sine theta. So we've got sine theta squared, we've got sine theta, and then we've got our constant term. All right. Now, one thing that may help you see this is when you see a sine theta, you do a substitution. Okay, so if it helps you, great. If it doesn't, well, got to think back to college algebra. Okay, so I'm going to let u equal sine theta here. Okay, and if I let u do a U-Substitution, okay, U-Substitution pops us big in calculus when you start talking about indefinite integrals. So I'm going to do 2, and then now I don't have sine theta, I have sine squared theta. Well, how do I get that from this? I square both of these, and I get sine squared theta equals u squared. So I replace sine squared with u squared minus 3, and then sine theta is equal to u, 3u, plus 1 equals 0, okay? And when I look at this, I think, all right, I have a trinomial. I should be thinking a t-chart, factoring, AC method. So AC method says I multiply the first times the last, and I get 2 times 1, which is 2. So I want something that adds to negative 3 and multiplies the 2. This is the AC method. AC, Austin Clark, right? Angelina College, there we go. Works out right. Okay, so I want it to multiply to 2 and add to negative 3. Can I do that? Negative 2 times negative 1, and that gets me 2. And negative 2 plus negative 1 gets me negative 3. So that works. Bingo. So these tell me the numbers I put in. So I'm going to do 2u squared, and I'm going to do minus 2u minus u. So that's that minus 1, and then that minus 2 get used here and here. And then I have plus 1 equal to 0. Okay. When I look at this, all right, I have 4 terms. Anytime I have 4 terms, I think factor by grouping. So I'm going to group the first 2, I'm going to group the second 2, and I want to make sure there's a plus in between. Okay, so this works for any trinomial that can be factored. So not everything can be factored, but this one will factor. So what can I do? GCF both of these. I can take a 2u out. So if I take a 2u out, what do I have left? I have u. Okay, so I have a u left inside, and then a minus 1. And I'm going to close that parentheses there. Now, what's inside here? This is a negative u plus 1. I want it to look just like this here, So what I'm going to do is I'm going to pull out a -1. And what do I have left whenever I divide through by a -1? Well, I have u minus 1, which is exactly what I wanted in there. Okay, so that's equal to 0. So what's in common between these two? A u minus 1 factor. And if I factor that out of both of those, then what do I have left? I have left 2u minus 1. And then that's equal to 0. So I have two factors multiplied together equals 0. The zero factor property tells me that I set each piece equal to 0. So, and then I solve for u, and so u equals 1, and add 1, I get 2u equals 1, so u equals 1/2. But recall, u is sine theta. So I have sine theta equals 1, and sine theta equals 1/2. Okay, so in the interval from 0 to 2 pi, do we ever equal 1? Well, let's think about it on a unit circle. Only place I equal 1 is right here at pi over 2. Okay, that gets me 1 there. And then 1/2, I actually have it at 2 places. Okay. So what's going on here? This is theta equal to pi over 2. Okay. Theta equal to pi over 2 gets me a solution there. But what about here? How do I get 1/2? I get it with pi over 6 angle, but also I get it with 5 pi over 6 for that angle. Okay? So theta equal to pi over 6 and 5 pi over 6. Using my coterminal angle tricks. All right. We're doing okay. Square root 3 over 2 here and 1/2 for that point there. Right. So gotta know those critical points on your unit circle. Can't say it enough how important it is to know your unit circle. So the solution set is pi over 6, 5 pi over 6, and pi over 2. Those are the solutions to my equation that I had, a quadratic. Now, let's do one a little bit different. It's basically one more step added to it. So let's solve the equation 3 cosine theta plus 3 equals 2 sine squared theta, 0 to 2 pi. Okay. Now, the quadratic, or the equation in its present form contains sines, but it also contains cosines. But we can use the Pythagorean identity to help get rid of the sine. Why do I want to get rid of the sine? Well, look, we don't have an identity yet that can turn this cosine into a sine, okay? So what we do have an identity for is sine squared. We know that sine squared theta plus cosine squared theta equals 1. So if I want to get rid of sine squared theta, or I want to write it in terms of cosine, then sine squared theta is 1 minus cosine squared theta. Okay? So I'm going to replace this, and so my new equation is 3 cosine theta plus 3 equals 2, and then in parentheses I'm going to substitute. What am I going to substitute? Sine squared theta, what does it equal? It equals 1 minus cosine squared theta. Okay? Now I'm going to distribute, so I have 3 cosine theta plus 3 equals 2 minus 2 cosine squared theta. So we'll move everything over to one side, have it equal to 0 to put a quadratic in terms of cosine. So I'm going to subtract 2 and add 2 cosine squared. Okay, subtract 2 and add 2 cosine squared theta. So I have 2 cosine squared theta plus 3 cosine theta plus 1 equals 0. Okay? Now, I've got a trigonometric function that is a quadratic in cosine. Okay? So I'm going to let u equal cosine theta. So everywhere I see a cosine theta, I'm going to put u. And everywhere I see a cosine squared theta, I'm going to put u squared. Okay? So this is 2u squared plus 3u plus 1 equals 0. Now I've got to do AC method again. A times C. Why am I calling it the AC method? You think about this as the ax squared plus bx plus c equal to 0. It's the first times that last there, okay? So the lead coefficient times that constant term. So I get my little t-chart, trinomial t-chart. I want it to add to 3, and I want it to multiply to 2. 2 times 1 is 2. So 2 times 1 gets me 2. 2 plus 1 gets me 3. So my numbers here are 2 and 1. So that tells me how to divvy up this. I want it to split it up to 2u and 1u. So I add 2u plus 1u plus 1 equal to 0. 4 terms, factor by grouping. Group the first two, group the second two. Make sure there's a plus in between. What's in common between both of those? There's a 2u. So I'm going to factor a 2u out. What does that leave me inside? It leaves me a u, and it leaves me a plus 1. Now with this one, there's nothing in common between u and 1, but I can always pull a 1 out. Okay, so I'm going to pull a 1 out here. So pull my 1 out, and what do I have left? Well, what I just started with. If I multiply back through, I get u plus 1. So what's in common between the two? There's a u plus 1 here and a u plus 1 there. And if I factor that out of both terms, I'm left with 2u plus 1. Set that all equal to 0. Solve for u. U plus 1 equals 0. 2u plus 1 equals 0. So what does this tell me? U equals negative 1, and u equals, let's see, minus 1 divided by 2 is negative 1/2. What was u? U was cosine theta. Okay, so cosine theta. Now, does cosine theta ever equal negative 1? Yeah, it does with a unit circle. It equals negative 1 over here with a theta equal to pi. Okay, so theta equals pi produces that negative 1. What about negative 1/2? Negative 1/2 is, I think, right here and then right here. So that's a negative 1/2 square root 3 over 2 and a negative 1/2 negative square root 3 over 2. Okay, so what are those angles? That angle there is, I believe, 2 pi over 3. Let me check. Nope, I'm wrong. It's 4 pi over 3. Yeah, no, I was right. Okay, it is 2 pi. So 2 pi over 3 for that first one, and then to go all the way around is 4 pi over 3. Okay? So you can use reference angles if you are having trouble, you don't have that memorized. You know you're going up pi over 3. So if I know pi minus pi over 3 gets me 2 pi over 3. And then this reference angle down here, that's a pi over 3. But if I went all the way here, I'm adding pi to that. That gets me the 4 pi over 3, okay? So theta equals 2 pi over 3, but also 4 pi over 3. So the solution here, the solution set is equal to, it's 2 pi over 3 comma pi and 4 pi over 3. Okay? All right. Hopefully that helps you get a little bit better at solving trigonometric equations in quadratic. The trick really is just taking it. If you have to use a Pythagorean identity, do it. But then when you do a U-Substitution, you're going back to college algebra. Okay, and then when your final step after you solve for each U, then you just substitute back in your trig, and that's when the trig comes into play. Okay, and then you got to know your unit circle. Got to know the unit circle. That's where it all falls down to. So let's do one more of these. I want to solve the equation cosine squared theta plus sine theta equals 2 on 0 to 2 pi. Okay. So once again, we've got a quadratic. Now, the problem is I've got sines and I've got cosines. So since I have this linear sign, I want to make this in terms of sine theta, okay? Because I can't get rid of that sine theta, but I can change this sine squared, or that cosine squared into something in terms of sine. So cosine squared theta is equal to 1 minus sine squared theta from the Pythagorean identity. And so this equation becomes, I'm going to replace cosine squared with 1 minus sine squared theta, and then I have sine theta equal to 2. So if I'm going to solve this, I'm going to subtract 2 from both sides. And so what do I have? Well, actually, you know what? Yeah, that's fine. So negative 1 minus sine squared theta plus sine theta equal to 0. I don't like this because my lead coefficient is negative. So I'm going to multiply everything by negative 1. And so that changes the sign of everything. 0 times negative 1 is just 0. This becomes positive 1. This becomes positive sine squared theta. This becomes minus sine theta. Okay? At this point, I'm going to do a U-substitution. And U squared equals sine squared theta. And so I have U squared minus U and a plus 1. So that's U squared minus U plus 1 equal to 0. Okay, does this factor? Well, let's see here. AC method, I need something that multiplies to 1 and adds to negative 1. Well, 1 times 1 and 1 plus 1, that doesn't work. Negative 1 and a negative 1, that's 1. But negative 1 minus 1, that doesn't work. So there's no way I can factor this. Well, what about the quadratic formula? Okay, quadratic formula. If you remember, u is equal to negative b plus or minus square root b squared minus 4ac over 2a, right? So a here is 1, b here is negative 1, and c is 1. Okay, coming right here from those coefficients. So that gets me negative 1 plus or minus square root negative 1 squared minus 4 times 1 times 1 over 2 times 1. This is 1 plus or minus square root. Now that's 1 minus 4 is negative 3 over 2. Uh-oh. We have not talked about taking the square root of negative numbers in this class. Since the discriminant here, b squared minus 4ac, is negative, that's less than 0, Okay, therefore there are no real solutions for this. And we're dealing with real numbers, so no real solution. Okay, so the solution set is the empty set. And in math, we denote the empty set with a 0 with a slash through it. Or you can write, a little curly bracket with nothing in it. Okay, so those are notation. So any of these answers I will accept on your exam, okay? So keep that in mind. You don't always have to have a solution here, right? And we could graph this and see if it, just to show you that they don't cross, right? So let's just, why not, right? So what was it? It was cosine. Let me try this again. Okay, let's do cosine squared. I'm going to do cosine of x in parentheses, and then I'm going to square it. And then I said what? Plus sine of x. Okay. And then I'm going to have that equal to 2. So when I graph that, do you see, when I look at this, it never does cross, okay? So it's kind of funky looking, right? So it never does cross, therefore there are no real solutions. Now complex solutions, sure, but we're not doing complex trigonometry today, okay? So no real solutions going on here. All right, guys, good luck doing those quadratics.